Hey everybody, Thomas here from my channel Astronize and welcome to another video. Today we are going to talk about something a little bit awkward, and I will tell you just in a moment why this is a little bit awkward for those of you especially who are watching my videos for a longer time now. But first, let's take a look here at Saturn. Yes, this is Saturn, and I also made a YouTube short video about this yesterday because this weekend is kind of special because every few years, 14, 15 years or so, we cannot see the rings of Saturn because we have an edge on view on the rings. So this is now the actual date time now, but if we increase, for example, the years, we will see that the rings will reappear until they have a maximum at around 2033, and then they will disappear a few years later. Okay, now let's take a look at my repository. If we go to Compressed Cosmos, you will see that we have now 2 Saturn ring videos. Well, codes. The thing is that although the idea space for my YouTube channel is very huge and I have a large backlog with ideas, I somehow didn't check what I already did already. So I was thinking, hey, the Saturn ring has an edge on view this weekend, let's create a code for it. And then afterwards I found out that I already did that. Well, but instead of not publishing the video, I was thinking let's publish it anyway because there's one major difference. In the last one I used a library called FM. Now I use a library called AstroPy. And AstroPy is like the golden standard for astronomy. So everybody is using it, or a lot of people are using it in the professional astronomy community. So here in this script, let's click on open in Colab, and an instance is then being started or set up. So we have to click here on connect, and the warning will also spawn when we execute the code. Let's execute the first part here where we simply determine we simply set the starting and end time for our computation, basically this year with 1000 steps, so around 3 computations a day. And then we compute the position of Saturn and Earth in an Earth-centric ICRS coordinate system. Now, there are two things. First of all, we compute the coordinate system to Saturn and then to Earth, but in an Earth-centric system doesn't really make sense. But the ICRS has been defined at some point, so the current position deviates now from this reference point that was been set in the past. So we have like a deviation of a few hundred or 1,000 kilometers. Now, for our computations, theoretically, you could remove this part here, so the Earth part, but I just wanted to keep it and show you that, how to make the calculations maybe even more precise. Now, after computing the position to Saturn from Earth, so we are looking now to Saturn from our home planet, we compute now the coordinate system of the, execute please, okay, of the rotational axis, so where the north pole of the rotational axis of Saturn is, because we assume that the ring of Saturn is perpendicular to the rotational axis. So when like this is the axis, the ring is around it. So what we have to do is we have to compute the angle between our viewpoint to Saturn and this rotational angle that is always fixed, because where's the camera? There. Now if the sun is here, the this rotational angle will stay fixed. Yes, it will wobble a little bit, but let's keep it as a steady state vector. And the only vector that changes is our viewing direction from Earth, because, well, the position of Saturn and Earth apparently depend on the time, the date time. But if we compute the angle, we have to subtract afterwards also 90 degrees because we want to compute the opening angle to the ring plane. And if the ring is perpendicular to the axis and we look perpendicular to the axis, then we have an edge on view on the ring. And this is what we do basically in the next steps. First, we set up the right ascension and declination coordinates for our Saturn's north pole, the rotational north pole. And I got the values from Wikipedia, but you can also take it from NASA and also. Then we convert it to a spherical representation. and then afterwards reconverted to some Cartesian coordinates. So we have a vector again. And then computing the angle between two vectors is basically computing the dot product and then dividing it by the magnitudes, applying the arcus cosinus, and then converting it back to degrees, what is being done here in this part. And the minus 90 degrees is being computed here in line 16. So we execute this one as well. And what we get is a list of angles, opening angles between the observer and the ring. And now afterwards, we can simply create a matplotlib cell where we plot the ring angles versus the date times that we defined in the very beginning of our script. Some fancy formatting and so on, executing the script. And then we see here the opening angle versus the time. And we see 0 degrees, which corresponds to an edge-on view, is here at around, mid-end of March this year, which actually corresponds to what we have seen in Stellarium. The only disadvantage or caveat here is that Saturn is very, very close to the Sun. So we cannot really observe it from Earth, and don't look into the Sun with your telescope. You know, it's not good for your eyes. You can get blind. So don't try it out. But you can simulate it in a software like Stellarium that I showed you in the very beginning. Yeah, I hope the next video will not be redundant, but at least we have a starting point here using AstroPy. See you next time.